Hello everyone. So today we are going to look into how to add multiple sections to this runtime generated terrain. So now here you can see I have added two additional parameters, number of sections X and number of sections Y. To easily demonstrate that, if I go to the top level here, if I make this one by one, now you see this is what you get. So if I stop the game, because this is generated in the runtime, so we have to play to see the change. Now if I make x2 and y1, so you get this. So basically here we have two sections of the terrain. It's like one section is like this and the next section is like this, two equal sections. So if I go back to the perspective mode, here is the terrain. Now if I make it 3 by 3, this will be even bigger, something like this. So yeah, that's what we are going to work on today. So the reason that I'm working on this sections system is so that we can have multiple tiles of the same landscape, so that we can start to work on a system that generate the terrain as the player move throughout the world, so we can have a infinitely generated terrain. And before we get started, I'd like to remind you that you can download the project files of this project and all other projects that I have done in my channel in Patreon page for the membership. So once you become a member, you can download all of them without a limit. So I'll leave the link in description below. It would help me to keep what I'm doing, so feel free to check it out. And let's get back to the tutorial. Alright, so in our runtime terrain generation system, this is what we have implemented so far. So if I play, you can get an idea about the scale. So now the next step I want to add is, so here we only have one section of the mesh. So instead of that, I want to have multiple sections. The reason to add multiple sections is so that I can have, say, 4 by 4 sections. So let's say maybe in a plane or in an aircraft, we fly through this land or we walk through this land somehow. And as we go through this land, some sections needs to be spawned in front of us where we heading, so that we can get an illusion of an infinite landscape. So that's the next step. So for that, I want to have a way to add multiple sections. So as you know, here so far we only create this one mesh section. So to support multiple sections, first I'll replace these vertices, triangles and normals. I don't think I use normals now. And UVs into local variables of this generate terrain function, so that I can call this generate terrain function multiple times, so that we can have multiple different sections. Okay, so first here, promote to local variable vertices. Wait, that may not be a good idea. I need a different name. Vertices G. G stands for global. Triangles G. And UVs 0G. Okay. Now I'll promote a variable vertices. Okay, and this one we here is, and here we need triangles. Triangles. Right, now I can replace vertices G, replace with vertices, UVG replace with UVs, triangles G replace with triangles, vertices G again replace with vertices, UVG replace with UVs, and I have to replace everything here. Every place I have used these variables. Okay, I think that's it. Now we can delete this. Right. Let me check. It still works. Yeah, still works without any issue. Now I'll add another variable, num of sections x, number of sections in x direction. I'll make this public, and another one, num of sections y, sections. This one also public, so we can modify this. By default I'll make it 1, and then we need to generate the terrain. So x number of sections x into number of sections y, that many sections we need to generate. So let me run a for loop, 2 for loops actually. And the first loop starts from 0 and ends from number of sections minus 1. Okay, and here ends from number of sections x minus 1. Okay, now even if I run this, so the terrain will be generated on the same place. So if I have, let's say if I have 2 x sections and 2 y sections, that means 2 into 2, 4. We will have a total of 4 sections, but it will be generated on the same location, so overlapping on each other. So that wouldn't make a difference. Also, we need to promote this section index to a variable and increment it as we add sections. So this has to be a global variable, because if I keep it local, this will always be 0 or whatever the default value. Then it will replace the same index. Okay, now so we need to add an offset to these vertices that I am adding. So for that I'll add 2 input. I'll call it x index in an integer where section index x, another one section index y. Okay, now here when we create this calculate this location, we need to add get section index x multiplied by cell size, not cell size, cell size into total number of vertex count. Maybe I should explain it. Here, let me go to top view and let me reduce this like 10 by 10 and this is 100. If I simulate, so these are all the vertices that I have, and here 0, we have 1 2 3 4 5 6 7 8 9 9 cells. Well, I actually need to have 10. Well, we may have some issue. Oh no, actually this count, vertex count, where it starts from here 1 2 3 4 5 6 7 8 9 10. Okay, total of we have 10 vertices since it start from 0. Okay, then first section starts from here and the next section should start from here. So if I make a screenshot and paint, so here, so the next section should be starting from here and the offset will be a number of x vertices. Actually, since we have only 9, a number of x vertices minus 1, so I'll call it n minus 1. N is the number of x vertices, nx into cell size. So that's the you can't read it, but that's what I tried to write. So that's the distance from here to here, and that should be the starting position of x coordinate for the next tile. Okay, and the same goes for the y also. ny minus 1 into cell size, that's the starting point. So we need to add it here. Section index multiplied by number of sections. Well, rather than doing this calculation for each value, yeah, we can do it only once here and promote to another local variable. Yeah, let's do that. And I don't want to pass this as a parameter because we may need this x index and y index later on as well. So this section index multiplied by number of sections x, it should be minus 1. Subtract 1. This is the origin of this section, the x index of x coordinate of the origin. We need to do the same thing. here section index y and minus, sorry, should be here, of sections y. Okay, now here I'll have another real local variable, offset. This should be a vector, set offset. So that's the offset we need to add to each vertex that we are calculating. This is x, this is y offset. Oh, sorry, not number of sections. This should be number of vertices, so x vertex count, and this should be y vertex count. Really sorry. Okay, right, now that's the offset, and we need to add this here, offset plus, wait, no, now before we add this we need to split x, add to this one, and y to this one. Now we forgot about the cell size. Let me collapse this. Calculate section offset. Right, now we need to multiply this with the cell size. Why two things are connected? Okay, do the same here. This multiplied by cell size and multiplied by section index y. Oh, what a silly mistake. I have connected y and z. Okay, yeah, it's correct now. So if I stop and make it 2 by 2 and play, you can see now we have 4 sections. Even though it looks like one section, we do have 4 sections. Now let me go back to perspective mode and play. Yeah, here. Okay, so we now don't see, let me make this large, 20 by 20, 3000. So yeah, here for the first one we see the texture, but not for the other ones. So why is that? Because we didn't make any change to the UV calculation, which we should have done. So here we don't take into consideration oh yeah, if we just use this, should work. Oh, hold on, no. So yeah, here we need, into this we need to add the section index x multiplied by x vertex count. Okay, right, just like before, but except we don't need to multiply it by this cell size. So I guess let me collapse. Calculate UVs, and first input is x, second input is y, first output is x, L, x out, second one is y out. Right, now here, as I said before, we can copy this part and this part and this part and this part. And multiply. And add. And plug as the output. Let's see. No. Oh, right. Here we may have to give the section index too. Yeah, and we see a seam, don't we? Yes, we do. But even though we have a seam, in close range it does look seamless. Why though? It is seamless. Oh wait. Well, maybe now I don't need this part. Let's see. No, if I don't have that, I do have a, it's not seamless. Yeah. See, it does not match clearly. Let's try with this. Well, at least in player's perspective, let's see. Oh. Too far. Well, even in player's perspective, we can see that. But let's say if we have foliage or something, that may not be a big deal, but still that is something we should learn to fix. So I'll try to fix that in a future episode, but for now I think it's better to stop at this episode. So now we have this point. So now we have a way to calculate and add multiple sections to our procedurally generated terrain. So thanks for watching. Now in the next episode, let's look into how to make this infinite, so that as the player goes, how to spawn multiple sections of the terrain indefinitely, so infinitely. So updated project files will be available for you to download in the parent page. Link would be in the description below, and see you in another episode. Goodbye.